This is the solution to practice problem number 9 from note 6.2. And this is a little simpler version of example 15 with Frank and the tree. So we're told that Chuck is in the top of a 150-foot fire tower, and he sees a bear at an angle of depression of 28 degrees. So remember, that's looking down from the horizontal. He looks closer to the tower and sees a hiker at an angle of depression of 43 degrees, and we're asked to find how far the hiker is from the bear. So I'm going to go ahead and make a sketch. So I'm going to draw the tower is 150 feet. And then I'm going to draw the ground, which is perpendicular to the tower. And then we're going to think about Chuck. He's at the top of the tower. So he's up here at the top of the tower. So I am going to draw in a horizontal line up here because I know I need to sketch in angles of depression, and those are drawn relative to the horizontal. So Chuck looks down. He sees a bear at an angle of depression of 28 degrees. So I'm going to draw a line going down at an angle of depression of, we'll call this 28 degrees. And this is the bear. And then he looks closer to the tower and at an angle of depression of 43 degrees. So we'll draw that, and we'll call this larger angle 43 degrees. He sees a hiker. And we're asked to find out how far the hiker is from the bear. So I'm going to call that distance X. That's this distance down here between the bear and the hiker. So you'll notice that the angles of depression are outside of our right triangles. So we need to move those angles into the triangle. So let's first look at the 28-degree angle. So we know that we have parallel lines because we have the horizontal line up here and the ground on the bottom. So we have parallel lines cut by a transversal, which means that we have alternate interior angles that are congruent. So the 28-degree angle up at the top is congruent to the 28-degree angle in the smaller triangle. So that's 20, I'm sorry, I did it in the wrong place. It's the smaller angle, so this is 28 degrees. And then the 43-degree angle, that's going to be an alternate interior angle with this angle here. So this is 43 degrees in the smaller triangle. So now we have the angles inside the triangles. And we're going to look at these two right triangles. So I'm going to look at the smaller triangle, the one that goes from the tower to the hiker. And I'm going to look at what we know. So we know 43 degrees, and we know the height of the tower is 150. And we'd like to know this base down here. So I'm going to call that Y. And I'm going to set up, we know the opposite, and we want to know the adjacent. So I'm going to set up a trig ratio with tangent. So tangent of 43 degrees is the length of the opposite side, which is 150 over y. And unlike in the previous problem with Frank, we don't need to solve a system here. So we can figure out what y is. So multiply both sides of the equation by y. So we'll get y tangent 43 equals 150, and divide both sides of the equation by tangent 43 degrees. And if we enter that into the calculator, 150 over tangent 43 is 160.86 feet. So this distance on the smaller triangle is 160.86 feet. Now we're going to look at the larger triangle. I'll highlight that in green. Let me get the green highlighter. So we're going to look at the larger triangle. And for convenience, I'm going to say that this whole base is equal to, let's call the length A. And then we can go and substitute in with X and Y later. So looking at the green triangle, I can set up a ratio an equation using this 28-degree angle and the length of the opposite side and the adjacent side. So now I can say that tangent of 28 degrees is the length of the opposite side, which is 150, over the length of the adjacent side, which I'm calling A right now. So let's solve for A. Multiply both sides of the equation by A. So A tangent 28 equals 150, and then A is 150 over tangent 28. If we enter that into our calculator, we'll get that A is 282.11 feet. But really what we're asked to find is the distance between the hiker and the bear. So the distance between the hiker and the bear is going to be this little piece right here that we called X. But if we look at the base, we know that A is equal to 282.11. We know that Y is 160.86. So the distance that we want to know is X is equal to the length of the whole base, 282.11, minus the length of Y, which is the length on the smaller triangle, which is 160.86. And if we subtract those two, we get, so in terms of our lengths before, this was A minus Y. We'll find that X is 121.3 feet. So the hiker is 121.3 feet from the bear.